This video is a quick overview to show you what we'll have done by the end of this section. We will have our character running around in our world, navigating seamlessly around objects, looking cool with a full blend tree animation that we'll set up from scratch. Here we are in our scene. You'll see that we'll set up a simple terrain, just drop a couple of placeholder houses in there, a little bit of structure, no need to go to town just yet. Set up our navigation using a nav mesh and putting a nav mesh agent on our player, so the player does some really cool things, like just understands that it needs to go around objects that are marked as static in the world. You can see there, just kind of figures it out like a clever little sausage that he is. Great work. And you can see our blend tree down here, which will be part of our animator system. There we go. Just one state of locomotion in a blend tree, dropping in a couple of assets, and implementing a follow camera to follow the player around. So let's jump in and start getting a little bit of a sandbox together so we can make movement for our game. So the player can bump into stuff and we can get our nav mesh working in future videos. First thing, we need to create a new project. So I've opened up Unity Hub. Click on the new button up in the top right. I'm going to name my project RPG Project. The location, I'm putting it in a repos folder and a folder within that is RPG. Click on the three buttons here to change your folder. 2018.3.3 is what I'm using, as I've mentioned, and 3D template. Click Create Project, and we're going to start creating our Unity project. That'll take a moment, so you might want to pause the video. I'm going to stop recording, and I'll fire it back up again when it's all ready and raring. Now my project's loaded. I'm going to go into my hierarchy, right-click, create a 3D object and terrain. We'll drop one of those in. Double click to find where it is. There we go there. It's absolutely massive at the moment. We don't need it so big for our sandbox. So while clicked on terrain, I'm going to go over to the inspector. I'm going to click on the cog here and scroll down until I find, where is it here? Mesh resolution, terrain width, I will change to 100. And then terrain length, I'm going to change to 100 as well, just so it's not quite so massive. Double click on terrain again so it zooms it in a little bit. There we go, great. Scroll back up on Inspector. I'm going to also reposition it so that the middle point of my terrain is at the 0, 0 origin point of our world. At the moment, the bottom left corner is at the 0, 0. So then I need to change this to -50 on the X and -50 on the Z or Z. Depends where you're from. Why is that? Well, the terrain is 100 in width, so I need to move it to the left 50 and down 50, basically. So now when I go and drop in my player, which I'm going to do right now, should be in the center. So over in the hierarchy, right click 3D object. For now we're just going to use a simple old capsule to say what our player is, and then over on transform, right click on transform, reset. That'll put it right back in the middle of our world. Double click on capsule, zoom right in. You can see it's gone underneath our terrain, so I'm going to increase my Y value to 1 on my capsule just to bring it up a little bit in the world. While I'm here, I'm going to change the name of capsule to player. This is going to be our player. Hit enter and then drag the player down on top of the assets folder to turn it into a prefab. Okay, and as I've mentioned before, I'm not going to go through and explain all these fundamental details like the transform and the X value and the Y value and prefabbing and stuff. I'll show you it as I go. So if you haven't done this before, you can follow along. But if these things are new to you, you should probably go and jump into our introductory 3D course for a little bit just to get the fundamentals, because I'm going to be going pretty fast in this course. Okay, I know I've told you that a couple of times. I just want to make it really clear that if you're getting stuck, that you might just need to go and do a little bit of a refresher. Okay, so now we have our terrain, we have our player. What do we want to do next? Well, I've got a couple of goodies for you to import to make this process a little bit easier. So go to the resources against this lecture, the place where you can get the downloads. And in there you will find, I've downloaded this already, but go and grab them and download them. You'll see 2 zip files. You need to unzip those zip files. I do that by just right-clicking and dragging and then saying extract here, but you might have a different method on your particular computer. We'll go for the first one. We'll go for our terrain textures. Just drag that over on top of assets, bloink, and that will give us, you might need to click underneath, give us the option to import the package. Click on import. And now we can see we have an asset pack folder with terrain textures that we're going to use to just paint our terrain, our sandbox terrain, make it a little bit prettier. And then the other one is the Cinti Sandbox V1. Drag that over onto your assets as well. That's giving us just a few assets from our asset pack provider, which I'm going to talk about a bunch later on. Don't want to go in too much detail just yet, but I'll tell you all about Cinti and how awesome they are. They've given us tons of assets. This is just a very, very small sample of it. to get us going. I haven't wanted to bog us down with a gazillion assets just yet. Just a couple of houses to drop into our scene. Okay, so we have our terrain. We've got our textures. What I'll do while you're watching, before I give you the challenge, I'll just give you a very quick rundown on the terrain. If it's been a while, if you've not done this before, then click on your terrain. Nice big terrain here. Terrains we can raise and lower. We can paint it. So click on the first brush here, the paint terrain, and then you've got a little pull down. This is different in 2018.3 to what it has been. We can create neighbor terrains. Don't worry about that just yet. Raise or lower and paint texture. They're the two we're going to be concentrating on. So if you click raise or lower, you have your brush size, you have the opacity, and you can choose the brush type. So what it looks like, this looks like a star. That looks more like a circly thing. If we increase our brush size a little bit, then we can go around. If you left click, then it raises the terrain, and it might went up massively fast there. The higher the opacity, the faster it'll go up, like bang. Just going to undo that. The lower the opacity, the slower it will go up. Now, if you want to decrease, you hold down Shift and then move your, and Shift and left click, and then move your mouse around, and it will lower the terrain. Okay, so that's lowering the terrain. The other thing I'll show you briefly before the challenge is if you go to Paint Texture, so click on where we currently have raise or lower terrain, click on Paint Texture. Currently we have no textures to paint, so it's empty. If you click on Edit Terrain Layers, Create Layer, we've imported these colors in here. We've got these couple of grasses, a bit of cracked mud type stuff. We've got this full-on mud. So I'm going to just grab this dark green, double click on that, and that will instantly create a layer, and because we don't have any other layers, it will apply that layer as the default to our terrain. So our entire terrain has now been colored as a green and looks a little bit more pleasant than having it as a white. And then the last thing I will show you before the challenge, I feel like I've said last thing a couple of times before the challenge, but here is the true last thing, is if you click on the Cinti pack and then expand that open, you'll see Materials, Models, Prefabs. We're interested in the prefabs. This is where we can go and grab any of these buildings. There's 2 buildings, a crate, and 2 trees, just for us to play around with in our sandbox. Drag that into the scene, and blink, there it is in our scene. So that's all the tools that you need for the challenge that I'm about to give you, which is to make a simple sandbox level. We're at a capsule. We've done this already. Placeholder for player. Great. Create a terrain with some ups and downs. Now we need to test our nav mesh. So make sure you've got some steep slopes, some gentle slopes, and some things where you just don't want the player to be able to walk through, to make sure that our nav mesh is working properly in future videos. Paint a path or two just so it says this is where you should be walking, and drop in a couple of houses. We need them so that we can test that our static objects are preventing the nav mesh from being created in that particular spot. And to share your creation with the community, if you put some time into it and you come up with something you think's pretty cool, then please do share a screenshot with our community. I've given you a link against this lecture, which will take you to a place that you can share your screenshot and see what other people have come up with. Oh, and before you jump in, just something very quickly I want to show you to make sure that your computer doesn't grind to a halt. If you go up to Window and General and choose, Window and Rendering and choose Lighting Settings, that will give you the Lighting tab. Scroll all the way down to the bottom. Where you see Auto Generate, you want to click off Auto Generate. If that's on, then anytime you make a change to your terrain, it's going to be regenerating the light map, and that can really make things grind to a halt. So turn that off. Anytime you think, oh, this is looking pretty neat, I want the lighting to look nice, just click the Generate Lighting button, and that will make the lighting generate based upon what you've got in your scene at the moment. Okay, so there we go. There's your challenge. Jump in, get started, and I'll see you back here when you're done. Okay, I'm going to start with a 20-ish brush size, pretty low opacity, just at 8. Just go around the outside of my world, just click, 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 and just create a little bit of mountains to say to the player, hey, please don't walk off the edge of my terrain because you will fall down into the nether regions. Is that the name of what you... That doesn't quite sound right. I think I might have mixed up some concepts there. But anyway, you'll fall down into some world, and that won't be so pleasant for the player. Okay, so a little bit of an outside, and then I'm going to turn my opacity down even more so it's not going quite so aggressively, and just make a little bit of a mound hill type thing in here, just so I can be testing out my nav mesh going up on a slope to make sure the player can go up and down and stuff, and that doesn't get stuck if there's a little bit of a bump. Okay, that looks pretty good. Should be able to walk up that. Shouldn't be able to walk up that bit there. Great. Okay, now let's just make a little bit of a path through our world, so I'm going to click on the paint texture, add a couple of extra layers, so create layer, make some brown mud, edit layer, and make some light green, and edit layer, and what's the other one I want? Just some brown dirt, I guess. You can do whatever you want in yours, Now, I'm just going to paint a little bit more interesting green on there. So I've clicked on my green, scroll down, that all looks pretty good. Got a brush. Yep, you can see it's getting in there a little bit faintly, just because I don't like big solid walls of one particular color. So we're going to have a little bit of patchiness in our green. Okay, just, now I feel better. Okay, I know it's sandbox, we don't want to overinvest in this and put too much time in, but I want to start feeling like it's actually grass in a village, just a little bit. Now I'm going to click on the mud and probably make my brush a little bit smaller. Brush size, that's pretty good. Where's my path going to go? Well, we'll pretend it's coming around the mountain. Should be coming around the mountain and through the middle of town, doop-a-doop-doop, and then back out this way again, just so we can start seeing what it's like for the player to be running along a path. Get a little bit of that pseudo-realism into our sandbox. Okay, there we go. Just a little path. Paint your path however you want through your level, and maybe just a little bit of the other color dirt, just again to break it up a little bit. Not that it matters at all in the sandbox. Want to be fast and loose, just go quickly, do something that you're like, yep, that is good enough. Okay, I think I've got good enough now. Okay, so let's click on the one hut that we've got in there already. You might not have one, you can drag one in. I'm just going to position it over here a little bit. Click on the E tool, rotate it so the front door's facing the front. Control D or Command D if you're on the Mac to duplicate that, move it along a little bit. Just a couple, we don't need to have this super fancy, but I want to create some gaps that the player can walk in between to see what happens with the camera and to start testing out the limits with, well, how close or how far can we have our buildings in our game. Hit W, actually Control D, make another one of these guys, do a sideways one. We'll see how the relationship between the building and the terrain by putting this up a little bit further into the terrain. And you know what? I'm just going to hit R on my keyboard and scale this whole thing up a bunch. It's not supposed to look perfect or look realistic just at the moment. Just making ourselves a bit of a sandbox to play around with. Now I'll go and grab the other one, the Building Village 02. And just drop a couple of those in just to make sure that it looks how it's supposed to look, and duplicate that, put it over this side, duplicate again. Okay, that's pretty good. Don't want to overinvest in this, just have enough so we can test things out. And you know what, let's put a tree or two in. One tree, two trees, okay, around the back here, and no, that's a building, and 3 trees. Okay, there we go. Great. The other thing I want to do is put a crate in the middle of the road just to make sure that we have our avoidance correctly on. So I'm going to find the SM prop crate, drag that in. This one does need to be scaled up. Hit R, scale it up a little bit. W just to move it above the ground. Okay, so it is going to be right in the middle of the world just to make sure the player can run around things. Simulating a little bit what happens if there's an enemy in the middle of the road, so that we've got that. Okay, there's our little sandbox. It's looking pretty good. Let's go and organize our hierarchy a bit. So right-click, create empty, and we'll call this buildings, structures, environment. Okay, for now I'm just going to call it environment and shove everything in this environment. So grab the buildings. I'm just clicking on one, holding down Shift, grabbing the others, and then dragging it into environment. Okay, close up environment. I'm also going to drag the terrain and put that in there as well. Okay, so now everything in my environment, if I was to switch it all off, blink, there it is. Great, we've just got the player. The player, let's move the player roughly where we're going to want it to be. Okay, cool, got our player. Okay, we've got our player, we've got a couple of buildings, we've got our terrain, we've got a path going through it. It's all looking suitably sandboxy and ugly. Not a lot of effort gone into it just yet. That's exactly what we want. If yours looks roughly like this, then job done, well done. Please share with the community, and I will see you in the next video where we'll be getting some functionality for our player. Hello again, my friend. In this video, we're going to use Unity's nav mesh system, you can see the blue stuff there, to have our player move to a target in our scene. So let's jump in and get started. Soon we'll set up the functionality where we click to move our player, but for now we're going to make it a little bit automated, and to do that we'll have a target that we just make our player walk towards. So in my scene, I'm going to create a new object, 3D object. We'll make this a sphere, and we'll call it target. There we go, target. Target, I'm going to move just away from the player somewhere. It doesn't really matter. Have it down at ground level so there's no issues. Let me make it a little bit bigger so we can see it nice and easily. There we go. Looks fine. Okay. Next up, we want to just make sure that our camera is going to see the action. At the moment, if we look through our camera, or is it main camera, you can see our viewport down here. It's looking at, no, I don't know what, the ground or something. If while I'm selected on my camera, I move it around, you can see that update. Oh, there's my player just there. The camera is pointing at the player. So what I'll do is get my scene view in a spot where I like it. So I'm in the scene tab, just move around a little bit. That's where I can see most of the action go on. And then while the main camera is selected, go up to the game object and align with view. Means that the camera will be moved so that we see exactly what I see in my scene view here. So when I rotate around a little bit, you can see that my camera has now been moved to that spot where I was looking at just a second ago. This is what we see in our camera when we click play on the game. Okay, now for the most important part of this video, we need a nav mesh. So go to Window, find AI, and open up Navigation. In here we've got 4 tabs. Mostly we're going to be focused on the Bake tab for the moment. And if we have a look in our scene, look at your terrain and your buildings and stuff, when you click the Bake tab, take a moment, and then a lot of the place turns blue. This blue stuff is our navigation mesh. This is where our navigation agent is going to walk and say, I can walk here and not walk there. And you can see, I'll explain this in the next video. We'll go into a little bit more depth on how to fine-tune and control what's going on. But you can see here, there's this line around my building that says, well, the player can't walk through there. There's no navigation mesh, so we're not going to be able to walk into that particular area. Similarly, we can't walk on the side of the mountains because there is no navigation mesh there. So this is a way for the player to say, okay, where can I go? I can walk anywhere on the blue. I have to avoid spots where there is no blue. And for this particular lecture, we're going to say, let's just walk from here to the target point on the map. At any point in time, you can just click Rebake again. So if I clear it, it all goes away. And then there is no navigation mesh at the moment. If I click Bake, then it just rebakes it again. And as we tweak and tune stuff in the next video, you'll see that slight changes take place in our navigation mesh. The other thing we need to do is click on our player, go back to Inspector, make sure you're not still accidentally clicked on the Navigation tab, and we're going to add a new component. So click on Add Component and type in Nav Mesh Agent. So you see Nav Mesh Agent, click to add that. Nav Mesh Agent has a bunch of different cool stuff, speed, angular speed, acceleration, etc. This is what's driving the game object that the Nav Mesh Agent has been placed on. So we now have our player with a nav mesh agent that's going to move it. And it's going to move it where? You guessed it, it's going to move it along the nav mesh. And we're going to do that as a challenge. And this is a challenge where I think if you know this stuff, then it should be a good meaty challenge. If you don't know this stuff, I'm going to give you a couple of hints, so they should be able to figure it out. So what I'd like you to do is create a mover.cs script and attach that to the player. And then to serialize within this script, serialize a transform target variable that we can assign our target game object to. And then within the update method, you're going to have one line where we want to get the nav mesh agent component, so get component, and set its .destination value as the target's current position. Okay, so if you're feeling a little bit advanced, that's the challenge. It's a good intermediate challenge for an intermediate course, starting off with something meaty, hopefully. But if you look at that and you say, I've got no idea, not a problem. Here are the hints. So if that's enough, jump in, take on that challenge. If you want the hints, here they are. The hints are, the target is currently at target.position, and we use getComponent nav mesh agent.destination. So basically you're assigning the value of target position to the nav mesh agent's destination. And just as one last clue, you may need to add the unity.ai namespace. Okay, so there's enough clues in there that you should be able to piece it together pretty straightforwardly. If not, no worries, we'll go through it together, but give it your best shot. As if you've not been through our courses before, the most important part of our courses is taking on the challenge. So I implore you, whether you think this is really easy or really difficult, jump in, nonetheless, give it your best shot, and once you have given it your best shot and really thought about it, I'll see you back here and I'll show you my solution. Okay, so I think this is a pretty straightforward script to create. I will start off by giving myself a script folder, keep ourselves nice and neat, so create folder, scripts, and within my scripts folder, I will right-click, create C# script, and call this mover. Okay, mover, while I'm here, I often forget this step and I feel dumb afterwards. I'm going to attach it to, grab it and drag it over onto player. So that now is a mover component on the player. Great. Double click, open up mover. This will be our first real time in Visual Studio Code. Okay, and you can see our warnings come up again about .NET Core debugging. This is not something we need to worry about, so I'm going to X out of this dialog, go over to the settings, which is in the bottom left corner. You see the cog there. Click on that, scroll up to the settings, and from here, while clicked on the settings tab, I'm going to search for CLI. That will show me under extensions, so here on the left under extensions, C# configuration, click on that, and then suppress .NET install warning. So click the checkbox there, and our warning should be never more again seen. Okay, close the settings tab, and then back over to mover. I'm going to get rid of the start method, just leave in update, and at the start of our class, I'm going to serialize field, and this will be of type transform, and this will be called target. And then within our update, pretty straightforward, we're going to say get component, and then in our angle braces, it's the nav mesh agent we're getting, parentheses, dot destination, and that equals what? It equals target dot position. So it's basically saying change the destination for the nav mesh agent to the target dot position. Now we're getting a red squiggly line. What's that mean? Well, usually it means we're missing a namespace. Let's mouse over it. Could not be found. Yep, so up the top here, we're using Unity engine, and I know this one's going to be .ai, semicolon, and then our squiggly line is gone. Save this up, back over into Unity. Now we have on our player, just check that we did assign that. I think I even made mention that I often forgot to sign. Yep, so mover is a component on there. Cool. Now we find the target. We assign our target down into our target field. That means the player should walk to our target. We've set up our camera. Yes, there it is. Oh, some nice shadows and everything. Click on play. And there we go. Walking from A to B. Bloink, excellent. So that's the foundations, that's the fundamentals of using the nav mesh and applying a nav mesh agent to move from a certain point to another point. In the next video, we're going to get a little bit more complicated and just play around with obstacles, with static, and to look at the different variations we can have with our nav mesh tuning. So great work in this video, and I'll see you in the next video. In this video, we're going to make sure we know how nav mesh works by looking at the different values that we can change and setting up a little scenario where we implement a nav mesh obstacle, we change our buildings to static, we have some trees, and we have the player effortlessly figure out how to pathfind through the obstacles and up a slope to get to the target. So let's jump in and more deeply understand our nav mesh. I want to start with a quick reminder that one of the best places to get information is the Unity documentation, and I'm showing you here the advanced nav mesh bake settings, which we'll be talking about a bit in this video. It's a great place to go to read if I've said something that you haven't quite understood or you want just more depth to what we're talking about. This is the best place to go to for pretty much anything. If you go into Google and search for Unity docs, and then whatever it is you're interested in, for example, nav mesh obstacle, we're going to be talking about in this video a little bit, then Unity docs, Unity manual, nav mesh obstacle, find that there, and then it gives you a whole bunch of information on that. So obviously you can surf around through here, through the navigation system within the Unity manual, but just such a rich place to get information is in the Unity docs, and many lectures I will give you links to the topics we've been talking about. I'll give you the link to the Unity doc against the lecture, just something to have a look out for, but pretty sure you know how to use Google to search for it yourself if you can't find a link from me. Okay, so let's have a look at our nav mesh. I'm going to click on my terrain and then navigation, and you can see we've got the bits of blue, we've got jaggedy edges, and we've got bits where the blue is not there. So let's talk about that. If you click on the bake button, you can see a couple of values here. The agent radius, which is literally how close or how far the nav mesh is to the obstacles in your world. So if we make this really high, like that, rebake, then you can see the distance from our obstacles is quite massive. It makes this kind of odd little shape in the middle here. If I put it back down to, just Control Undo, if I put it to say 0.1, That's Control Z, not Control Undo. There's not an undo button. If you click bake when it's at point 1, then you should see, it's going to take a little bit of time, and then you can see when we come look at our building, it's really, really close, which means that our player is probably going to clip a little bit into the building. So we want to have something sensible. We play around with it, wait until you have your character actually complete, so you can see how fat your character is and how wide the arms are, so it doesn't actually look like it's walking through the building, so it makes sense. Okay, now why is it that these buildings have the nav mesh correctly calculated, but these buildings do not? It's because these buildings have been flagged as static. So click on Inspector, click on the building. You can see up in the very top right corner of the Inspector there's a tick box against static. If you click on the little pull down next to the word static, you can see these are the things that can or cannot be static, or you can turn on and off static. So navigation static is the one we're interested in, but usually it's holistically everything static or nothing static. So you can click on nothing, and then none of these things will be static. Whoops, sorry. Or you can click on everything and it's all static. And things like lighting and what else we've got in here? Batching and reflection probe. Most of these we don't even need to worry about at all. But static means it's not moving. It means we just want it to be a static, not moving blob in the world. And that way the navigation mesh will say, well, it's never going to move, so I can bake it into the navigation mesh. So these ones here, this building, you can see that static is not clicked on. So I'm just going to click on that. That's one way to do it. And then back to my navigation window, click on bake, and then you can see around here we have our navigation mesh is taking that into consideration, and we can't walk in this bit just in here. Interesting little artifact on the top, which I'll talk about in a moment. Now, if you want to make sure that all of your objects are static, click on all of the things that we need to have static, and I'm just holding down Control while I click through these, so I think all of my world assets. Then I can, back on the inspector, you can see how it's got next to static here, it's got this little dash, which means some things are static and some are not. Just click that so it's a tick, and now everything should be static. Back over to navigation, when we click on bake, all of these, including the trees, will have a appropriate navigation mesh calculation being made to it. Awesome! And the other couple of things I wanted to show you in this video, you can see over here on my mountain that we have some navigation mesh and some not navigation mesh. And that's changed by the slope. So you see here the maximum slope, and as I move this, the little angle indicator here goes up and down. If you have it really low, it means that only very gentle slopes can be walked up. So if I bake this, all of this mountain, you can't walk up it because it's too steep for the player. They couldn't possibly walk up that hill. If you put it all the way up to maximum, then you can nearly walk up the side of a cliff. So most of these, particularly this one over here, you can see it is now walkable, despite the fact it's pretty steep. If I put it back to 45 and then bake again, you can see part of that there is too steep for the player to walk up. If you're going to advanced, there's a couple of settings in here. The voxel size is just going to show how detailed things are, and you don't want to play around with it too much, but basically the more voxels per agent radius, the more fidelity, the more finesse you have to it. So if it's currently set to a default. If you click on the manual voxel size, the higher the number here, the less fidelity we have. So if I put that to 1, you can see here it's now showing 0.5 voxels per agent radius. Bake on that, and it makes everything just a little bit more macro, which is not too bad in a way. I think it simplifies it a lot. It's saying here's a nice big smooth edge. We're not having lots of little fiddly diddly bits. But if you want to have more more fidelity, like over here, for instance, now if we try to walk there, the player could not make that. If I put my target over this side of the building, and I put my player, where are you, player? Put my player over here, you can see when I click on play, hopefully it'll show up on the camera. I might have to click back to scene view. Yep, it's going to go the whole way around the house because it can't get through this bit here. But if I change my voxel size back to the 0.1 or so that it was, actually it's 0.1555, so 0.1777 I think it was. That looks pretty good. And then click bake. Now you can see that there is a path there because of the fidelity of our voxels per agent radius. And then the other important thing in here, you can see we've got these weird sort of on top of our buildings. That's because there's a flat part that the player could potentially walk on, but you can see there's no way to get up there, and we don't want to have any sort of weird accidental clicking on the top of a building. And what's happening there is that it's saying that the the space is large enough for us to have a region. So the minimum region is smaller than whatever this region here is. So if I put this up to 10 and bake, we'll see how that goes. Then it gets rid of that. It's saying whatever size this was too small to have nav mesh on top of. You can just see some other areas like on the top of this hill over here. If I was to put up, say, 30 as the minimum region, bake again, then that is no longer there. That was too small an area. And generally, if you've got a world that's mostly continuous, then you're not going to have any problems having a pretty high minimum region area, but it'll cut out some of those just little fiddly, like if there was a little bit of a spot in there that was okay and a little bit of a spot in there, it'll cut those out, just kind of makes it a little bit cleaner. So I'm going to put this back to, say, 20. I think that's not too bad. And then rebake. Okay, and there's another thing that's really super interesting. If you see my box just here, it is currently, when we click on Inspector, it's currently flagged as static, but what if I wanted my box to move? So what if I wanted to, as the player walked through a trigger volume down here, the box, I don't know, falls off the roof and lands in the way of the player, and the player then has to go around it, or the enemies have to run around it. So I'm going to click off static, because it's no longer static. If I was to rebake my nav mesh, you could see that it wouldn't impact the nav mesh, because it doesn't think it's something that is statically baked into the scene. And if I go on to my crate, click on my crate, add component, and add a nav mesh obstacle. This one's really cool. Nav mesh obstacle, and click on the carve. Carve means that it will carve a chunk out of the nav mesh. So I've clicked on carve, and go back to navigation. Don't even have to click on bake. You can see that as I move this around underneath the crate, there's going to be a gap in the nav mesh. So this is an area that if I was to say, you know what, I want to have the crate there, the player's going to avoid that. Or, you know what, I'm going to have it here. Let's make it dramatize this by having it even bigger so we can see this effect as I move it around. So if I move it to there and then move my target all the way over to here, bloop, 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 click on play. Let's do this dynamically. Back into scene. Okay, going around that way. Oh, now you can't. Which way you're trying to go? See how the player is readjusting where it's trying to get to as I move that nav mesh obstacle, which is really fun and really cool. Lots of great stuff that you can do with that. So speaking of lots of great stuff, let's create an interesting path. So I want you to double the speed of your player, if you can remember how to do that. Create a path where the player walks around a static object, avoids a nav mesh obstacle that you've placed in its path. You can move it around manually if you want to be sneaky, to walk through a clump of trees to make sure that we've got the fidelity right, and to walk up a hill to make sure that your slope setting is as you want it. So just take a couple of minutes to play around with your sandbox to set that up, and I'll see you back here when you're done. Okay, move our target over somewhere where we've just put on the navigation. Okay, over. I don't want to change the slope of that hill there. I'll put it just here. This is a good one. See what happens if we've got those two little weird navigation bits here. That one's obviously too steep, and that's too steep as well. Cool. I could fiddle around with my voxel size to get rid of those, but I want to see how the player goes when we've got a little bit of difficult situation for it here. So, move the house there. Go through the trees. This is cool. Put that other tree just there. Maybe duplicate the tree to make one more. And remember, always, we need to go back to bake. Click on bake again. Great. Now, let's see. Actually, I'll change the camera. Change the camera. So, find the camera. Main camera. Game object. Align with view. And I mentioned doubling our speed, so I'm going to click on my player. Back over to Inspector. Scroll down to Nav Mesh Agent. Change the speed to 7. You can make yours whatever you want. I'm making mine 7. Click on play. We should walk through the trees. Yep, around that box there. Just, effortlessly through the trees and up the slope to the target. There we go. So we've got our nav mesh. I'm pretty happy with this. We'll have to do some fine tuning when we have our enemies in there and when we have a whole bunch more obstacles. But for now, I think we've gone through nav mesh enough. It's time to get to the next type of functionality where we can click and move our player. So great work in this video, and I'll see you again soon. Here on the camera's near clipping plane, relates to what we are going to see as a player on our screen. And because I've got this weird kind of tall and skinny stretch on my game window at the moment, that's why these two look like that. And because we're in free aspect mode as well. And so if we start from the origin just here, and we move our mouse to say just there on the screen, then we're going to shoot a ray from that point to that point, and wherever it intersects a collision, which might be just there, we know that that is the point that the player was looking to click at. So that might correspond to, say, there on the screen. So that's how we're calculating, that's how we're getting that the player should be moving to that point. And to do that, we need a couple of nifty methods that I'm going to show you in a moment once I clear my screen. We're going to do two cool things. One is using debug.drawRay, which is where we need to know the start and we need to know the direction. We can also change the color if we want and a couple of other things, but mostly the start and the direction, as well as camera.screenPointToRay. And I've given you the link to both of these if you want to read up on them a little bit more, but these are the two methods we're going to be using. So back over into Unity, let's fire up our scripts, our mover script. Actually, you know what I just saw? Sample scene is still called sample scene. I'm going to change this to sandbox. So right click, rename, call it sandbox. You can leave it as sample scene if you want, but I want it to be known as sandbox. I'm going to save, which is Control S or Command S. And then now we'll find our scripts, open up mover. And within here, we want to create a variable which is going to be of type ray, and we'll call it last ray. So make yourself a new line of type ray, and it will be last ray. Why is it last ray? Well, it's the last ray that we've shot out at the screen. So just recognizing the fact that each time we create a new ray, the old one is gone, and we don't need to keep a connection to that anymore, a reference to it anymore. It's the last ray that we've shot. And within update, we will create ourselves an if statement. If, and then we're looking for input, capital I, input dot. Now, how is it? Little micro challenge for you. How do we know if we have clicked the left mouse button? If you know how to do that, just fill in the rest of this. It's going to be get mouse button down, and it is button 0. Usually. And then we've got our two double parentheses. And then on our next line, curly braces, we need to say last ray, that we've created our variable just up here, last ray equals. Now, how do we get our camera? If you remember that, little micro challenge for you again to test your memory. If you've done this in our other courses, we're going to be looking for camera.main. Camera.main is our main camera. And then we're going to be using the method I mentioned before, screenPointToRay. And where are we looking for? Well, pretty cool. We've got input dot mouse position. Okay. And then finally, we're going to use debug dot draw ray. And the starting point for this will be last ray dot origin. So the origin of our camera, comma, last ray dot direction. A lot of these things are already made for us. Now, we want to make the visualization of this quite long, so I'm going to times this by 100. But this means that our ray will be drawn way off into the distance. So now we click play, and you can see, as I click in various points on the screen, you can see that this ray is being shot out. Let me just move the camera around a little bit. You can see the ray is being shot to correspond to where I've clicked on the screen. So it's going from the camera to our terrain. Okay, so that's the first step in ray casting, visualizing the ray. Next up, we want to say, well, this is the point that we want to move our player to. And just a reminder, if you've got any questions at all about what we've covered in this video, or just ray casting in general, if you're confused, or even if you just want to summarize your understanding of what's going on, please do throw your questions into the Q&A, into our community forum, so that we can help you out and make sure that you don't get stuck. So great work in this video, and I'll see you in the next video. In this video, we're going to implement ray casting so that we click and our player moves in a nice, seamless, organic way around objects to the point that we've clicked. Let's jump in and get started. Okay, in a moment, I'm going to open up my mover script, but first of all, I forgot to rename my folder under my scenes folder. It's still called sample scene, so I'm going to change that to sandbox, just so it's nice and tidy. Okay, let's look at what we're trying to achieve here. We've got the player, and the player needs to move from A to B. What is B? Well, that's wherever we click. So this is the point that we click on our terrain. What do we do here? Well, we're shooting from our camera. Our camera is going to be over here somewhere, looking at the player. From our camera, we're going to raycast from the camera through our screen and find the point where we've clicked. And then after we find that point, we need to be giving that information back to the player, specifically the player's NavMesh agent component, NavMesh agent, to say to the NavMesh agent, this is the particular point we're interested in, please navigate, make your way to that particular point. So we need to create ourselves a method that we'll call probably move to cursor. And within move to cursor, we need to be creating the logic of did our ray hit somewhere on the terrain, and where did it hit on the terrain, and then move to that particular point. So let's jump in and take that on. Okay, let's find our script, open up mover. So a little bit of a refiguration here. So underneath update, we're going to keep if input.get mouse button down, but instead of having last ray in here, I'm going to grab my line, last ray, cut that and just pop it down the bottom underneath my debug draw ray. And you know, I'm going to delete debug.draw ray. We don't need that at all. That's just going to get in the way. Okay, and within my if statement here, I'm going to start by making a method move to cursor, parentheses, semicolon, and then just to close up our curly braces. And so what is this going to be? Well, new line, we will say private void, so no return type, move to cursor, parentheses, curly braces. What do we want to do? Well, a couple of things. We want to create a raycast, or call a raycast method. So physics.raycast. So what we'll type in. I want to show you something in here. As soon as you type the parentheses, you will get information about the options for the parameters to put within here for the different signatures. So hopefully this all makes sense and you remember this from other learning that you've done, but for each time we have a method, there's often different things that we can put within the parentheses, different parameters we can feed into it. And here you can see if we click down, we get other signatures, so other parameters, other different constructions of the parameters that we can put in there. You see a few of them in here that is taking in vector 3 origin, then vector 3 direction. So that is describing a ray that starts at an origin and has a particular direction. We've talked about that a bunch. If I scroll all the way down, I'll click all the way down to the very last one, which is 16. So you can see there's 16 different signatures for raycast. This one is very simple. It's taking in ray, so it's of type ray, and then a keyword out for a ray cast hit. And that's what we're going to do. We're going to say what the ray is. And remember, the ray is the origin point and the direction. Just another way of saying origin and direction is just saying ray. And then we want this out raycast hit to get some information about, well, where did you hit and what can we do with that? We need to know some information about that collision point. So we'll come back to this method in a moment. First of all, I'm going to create myself a couple of variables, local variables within move to cursor. So remember, we're only going to be able to use these within move to cursor and not anywhere else, not in update, not anywhere else within our class. So this first variable is going to be of type ray, and we'll call it just straight up ray, nice and clear, call it what it is. Call a duck, as they say. And we are going to go and grab our last ray we had before. So instead of calling it last ray, I'm going to call it ray just to make it a little bit more general, because we're going to be using this over and over. So camera.main screen point to ray input.mouse position. Going to cut that and then pop it in here as our ray definition. So ray equals, we have that there. And our second variable, remember if we go back to our signature, and if you can't find it, if you click within the parentheses in Visual Studio Code, if you hold down Control, Shift, Spacebar, that will bring up the signatures. And if you're on a Mac, then I believe it's Command, Shift, Spacebar. And if you're having trouble finding the shortcut keys, then you can come all the way up to Help and look for shortcut references. That will take you off to a website. And this website is going to show you a PDF of all the shortcut keys. So just a little hint there. I'm not going to go too much into all the different Visual Studio Code niftiness, but you can go and have a look at the shortcut keys. Lots of good stuff in there. So Control, Shift, Spacebar, and you can see, back to what we were talking about before, it's the 16th one. You can see we're looking for ray, and then we're looking for out raycast hit. So I need to create of type raycast hit. If I spell it correctly helps, yep, raycast hit, with a capital R and capital H, and I'm just going to call this straight up hit. We could call it hit information or hit details, but we'll call it hit, nice and clean. And then within my method now, I can be passing in the parameters of ray, and then comma, hit. So we're passing in ray and we're passing in hit. Now what's really interesting is we need to put in front of hit the keyword out. So that means, it's a little bit confusing, but that means we're passing in the parameter hit, but we're also retrieving out using the out keyword and storing in the hit variable information about where the raycast hit. So this is a way for us to be storing the position that raycast has hit into our raycast hit variable called hit. And the raycast method itself is a bool. So what we're going to do is store it as a bool variable. So we'll type bool has hit equals. So when has hit is true, we can do something with it, which we'll do in a moment. But first I want to take you to the Unity docs to have a quick look at raycast hit. And you can see when we're using raycast hit that we have a whole bunch of properties that we can access. So we can say raycast hit dot, and then any of these different things, and then to use the information within here. So, for example, the impact point in world space where the ray hit the collider. So in other words, where did we click within the world? That is a very important piece of information. And there's some other cool things that we can get within here. We might play around with these later on, but this is the important one for now, is point. So it would be raycast hit dot point will get us the impact point in world space. Okay, so back within our method in here, we've stored this as a bool. The last thing I'm going to do within my method is create an if statement. Well, actually I say I'm going to create it, but I'd like for you to create this as a challenge. And just to be super clear, I'm going to delete my little last ray that's hanging down there. So essentially what we want to do is, if we've hit something, then move to the point that we hit. So here is my challenge to finish the move to cursor method, create an if statement. Within that if statement, if hit is true, then change our nav mesh agent's destination to the impact point of our raycast hit. And I've given you all the information, I've given you all the clues to figure that out. It should be a reasonably straightforward challenge, but never fear, if you can't figure it out, give it a good few minutes to figure it out, and then once you've done that, I'll see you back here and we'll go through it together. So here's our if statement. If has hit, which is another way of saying if has hit equals true, then parentheses, our curly braces, we want to grab our get component navmesh.destination equals, okay, because that's saying where should our navmesh agent go to. What does it equal? Well, I was showing you a moment ago that if we say hit dot point, it will take us to the point, and then semicolon, take us to the point on our collision, wherever we've collided, that is where the destination is going to be. And then just clean it up, delete those last couple of lines that we don't need. Add one more curly bracket, curly brace, there we go. And then a final tidy up, back up the top, we can delete our variable ray, last ray, don't need that anymore. While I'm here, I'm just going to delete the comments around update, because we don't need that, we know what update does. Okay, let's save that, jump back over into Unity, wait for it to compile and do its magic. Now, all going to plan when I click on play, and then when I click anywhere in the world, aha, my nav mesh agent, therefore my player is going to move to that spot. We can do a little bit of tuning so that our player is moving with a bit more gusto, a little bit more speed. Click on player, scroll down to nav mesh agent. I'm going to make the speed a little bit quicker. I like to have a nice fast game, so I'll make that say 12. The acceleration I'm going to make 20. Stopping distance, that is all fine. So click on play. Okay, running around, yeah, a little bit quicker. A nice big turning circle, that could be the angular speed, which is fine. But if you're new to Unity, which hopefully you're not, but if you are new, then you know that you can make some changes here within, while we're in play mode. So I could say make this 500 for angular speed, and then that will update. But as soon as I click out of play mode, I will lose those changes, and then I'll have to make them again outside of play mode. So pretty sure you know this stuff, but just reminding you in case you've forgotten or you're a little bit new to Unity. Okay, so pretty exciting. We now have our player moving to wherever we click on our map, doing pathfinding, using the nav mesh to get around obstacles. Great stuff. I'll see you in the next video. Hello again, my friend. In this video, we're following our player around by implementing a follow camera. So let's jump in and get started. Okay, as we move around, we need our camera to move with us. What we could do is we could just grab the main camera and child that to the player by dragging it over the top of the player. Now, wherever the player goes, the camera will go. That's going to work, right? Well, sort of. As you can see, when we move around, the camera is also taking on the rotation of the player, as the player rotates, and it's kind of cool for about 10 seconds until you start to get really dizzy. So that's not what we want. So we have a problem. How do we lock the camera in position without it moving around, but still follow the player as the player moves? I'm just going to undo my camera drag just there. And while I'm here, I'm going to delete target because we don't need it. Okay, what we need to do is create a follow camera. Let me show you a slide. Follow camera. Here's our player looking happy. There's our camera pointing at the player. Now, what we need to do is create a follow camera game object that we can place at the exact same position of the player, and then to child the camera to the follow camera and have this relationship, this child-parent relationship, where the camera, the one we look through, is the child of the follow camera, or our game object. We could call it whatever we wanted here. We could call it the thing that follows the player, but we're going to call it a follow camera. And this fixed distance and angle is something that we can tweak and tune. We can rotate the camera a bit down or a bit up, move it closer, move it further away, but always in relation to where our follow camera game object is. So let's jump back to Unity and right-click, create empty, and name this follow camera. Excellente. So we go follow camera. What we need to do here is to create a script. So under our scripts folder, right-click, create C# script. I will call this follow camera. And then drag the follow camera script on top of the follow camera game object. So now you can see that follow camera is a component. Let's open up follow camera. All looks good. Time for a challenge. And here is our challenge. Attach the script to our follow camera game object. Well, we just did that, so I've given you one for free. Yay. And then we want to serialize a variable called target. And within our update method, make our camera's position be the value of the target's position. So there's going to be one line within update, which is camera's position equals target's position. And then, of course, don't forget to assign the player's game object as the target. So I haven't given you a lot of clues on the syntax for this. This is one of those intermediate challenges that I'm expecting that you kind of know it already. If you don't know it, not a problem at all. We'll go through it together in a moment. So take on that challenge, do your best, and I'll see you back here when you've given it your best shot. Okie dokie. For now, we're not going to use our start method or our commenting on update. We will create ourselves a nice new shiny variable which will be serialized. So serialize field, and this will be of type transform, and we'll call this target. Why is it of type transform? Well, we need to know the position. We need to know the transform. If we click on our player, you can see the transform here. We want to know that transform. We want to know the details of that. So that is why we've made it of type transform. And then within update, all we need to do is say transform with a small t dot position. So that's saying the position of whatever the follow camera script is attached to will equal target. This is our variable we've just made, target dot position. And if you didn't do the challenge, here's a good spot for you just to pause and do the last step in the process to hook all this up together back in Unity. So we'll jump over to Unity, little mini challenge for you, hook it up so that our camera is following our player. Okay, so first of all, click on follow camera. We need to drag our main camera to be a child. Remember my slide from before? Now the main camera is a child to the follow camera. And while I'm here, I'm going to click on follow camera and drag that down into assets to make that a prefab. It's probably time for us to tidy these up a little bit. So we've got scene scripts. I'm going to make a new folder, high-level folder here, create folder. I'm going to call this just game. These are things that just belong to the game. Player goes into game and follow camera goes into game. Okay, so now we have follow camera as a prefab. So clicking on follow camera, you can see that we have none as target. Click on my selector, find the player, or I could just drag the player on over. Player, and then I'm going to apply that back to the prefab. So up here under prefab, open select overrides, click on overrides, and then apply all. So now all of that is part of the follow camera prefab. Excellent, let's just see how that looks. Click on play. And moving, yes, so success. We are moving the camera. It's way off in the distance. Okay, so let's get in and tune our camera a little bit. So we'll click out of play mode, just move our screens around a little bit. I'm just going to pop my game window next to my scene window so that I can get my scene window looking a bit fuller. Okay, just wiggling around a little bit to get in position, roughly where I want the camera, about there. Not looking too much in the distance, but you could do that if you wanted, and not too far down. So around about there, decent angle. We'll tune it again a bit more later on. Now the first thing I want to do is to have my follow camera exactly on top of the player, because we're making a relationship between the camera and the follow camera. So the follow camera needs to start on the player. An easy way to do that is to hop on the player, go over to transform, right click, copy component, back over onto our follow camera, and on transform, right click and paste component values. That means it's now sitting right on top of our player. Then click on main camera, and we've done this before. We go up to game object, align with view, bloink. So that is now aligned. You can see if I click on follow camera, right on top of the player. If I click on main camera, it's looking at the follow camera. Now click on play. Hopefully our game window pops up and we can run around, and that's looking pretty good, eh? Not too bad at all. I like it. I like that, and I'm not going to get dizzy as the camera spins around. Okay, so feel free to tune that however your heart desires, but for now we've got movement of our player, we've got our camera moving around. Let's turn our attention to having our player look a little bit more interesting in some upcoming videos. Great work, and I'll see you again shortly. In this video, we're going to add an actual mesh for our player. We're going to add a blend tree, and we're going to set it up so that we can preview what happens when our character is walking, when our character is running. So let's jump in and get started. I have some asset packs for us to download first of all. So if you want to fight against this lecture, there's 2 asset packs zipped up. And so download those and unzip them into a folder of your choice. One is the Animations Unarmed Walk and Run, and the other is the Polygon Student Sample Cinti Studios 2.1. So what I'll do is unzip those and first of all drag the animations over into my project, and then you'll need to click Import. Excellent, as that comes in, that's pretty quick. And then the other one is the Polygon pack, so drag that over on top of assets as well, and import all of those. Now, this second pack is an expansion, or it's more assets from the existing assets that we have already, so it should go nice and neatly into the same folder, the Cinti Polygon Student Sample Pack. I want to take a moment just to talk to you about what these assets are and where they came from. There's a README that shows the usage rights, and it says this has been provided by Cinti Studios, and I'm going to show you some details on them in just a second, and you can use these for non-commercial use. So you're not allowed to sell these assets, and you're not allowed to put them into a game. There's a finished game that you're selling for money, but you can put them into your student project, and you can share it with your friends, and you can use it to improve your skills, and obviously go through this course with us. If you want to use them in a finished project, then you need to go ahead and buy the pack that they came from, or the packs that they came from the provider, and that is Cinti Studios. They're awesome. They've helped us out a bunch in the past, and they're really good folks, so I love supporting them. Here's some of their assets. I'm using, so I'll give you this link to their Facebook page in the resources against this lecture, and also I'll give you a link to the asset store, where you can find in the Unity asset store, the place of all greatness. I love the asset store, where you can find all of the Cinti Studio assets. I'm using the Polygon assets, and there's tons and tons of them, different packs, and if you're making a professional game, I think these assets look really slick, and they're a pretty good investment, I reckon. And from time to time, we get cool deals and discounts from these guys. So if we do, I'll have them as a link in the resources against this lecture as well. So hopefully you've downloaded now the assets and installed them or imported them into our project. Excellent. Let's go ahead and use them. You can see a couple of things first of all. I've got some new layers. This was from when we created our terrain. They're floating around a little bit. I'm just going to rename this new layer as green grass, just so I'm not confused in the future, and I'll drag it down into my terrain textures. I think also in our prefabs folder, which is the one we're interested in this new asset pack, the Cinti Polygon Student Sample Pack. You can see in prefabs we've got a bunch more. We've got a couple of characters. I'm going to drop them in the scene just so we can have a look at them. There's a cool one, there's a cool one. And I was saying before, I've got a couple of these new layers. That was from when we created the terrain textures earlier on. Yours might not be in here. I don't know why mine ended up in this folder, but I'm going to go ahead and rename them to something sensible and to drag them into the terrain textures folder. Grass layer, and drag that over into terrain textures. And the final one, which is, what's that, kind of light dirt. Light dirt layer. Okay. They weren't in the asset pack. They just happened to be saved in there for some reason. Okay, so what I've done, I've grabbed my two characters. I'm going to choose this character on the left, which is the Knight 02. I think he's looking pretty nifty. And we need to go ahead and instead of having our egg that we're driving around, we're going to have our character. So just delete my character out of the scene. Okay, ready for action. So go ahead and find your player. Here's a player here for us. First thing I'll do is reset the transform on the player. So right click, reset, just so I know that all the values are at 0, 0, and there's no wackiness going on. Double click on player in your hierarchy. That'll zoom you straight to it. Now I'm going to find from my Cinti prefabs folder, I'm going to grab character Knight Soldier 02. You can use 01 or 02. Drag it on top of player, which will child that to the player. So the player is parent, and the character with the mesh, in other words, the geometry of how it looks, and its materials, is now the child. And we can go ahead and get rid of the egg. So by clicking on player, we'll find the capsule, right-click on capsule, remove component. I'm also going to remove the capsule collider. If we need a collider, we'll put one on in the future, but right-click, remove component. And then we have the nav mesh agent. If I'm clicked on that, you'll see it's also kind of underground. That's because our base offset was changed because of the capsule. So click where it says 1 and change that to 0. Now it's at the right height. I want to make it a little bit skinnier, so the radius I'm going to change to 0.3, just so it hugs where the player's outline is. Cool stuff. I'm going to click on player, and I want to update the prefab for the player. So up in the top right, you'll see the overrides button. Click on that, and I'm going to apply all, which means all of the changes I just made to the Knight, and to the capsule collider, etc., are now part of the player prefab. So you can see that the Knight remains a prefab and the player is a prefab, and this is called nested prefabs. So prefabs within prefabs, and it's something that Sam and I are going to go into a lot more detail later on, in particular when we're making changes to prefabs within prefabs. So for now, let's just apply the changes to our player and keep moving on with our basic movement, but rest assured we are going to spend a lot of time exploring nested prefabs in upcoming videos. Okay, what next? Well, we need to make our player walk and run and move around, general locomotion. So I'm going to show you a couple of pieces of terminology. This will be a reminder for some of you. It'll be a new introduction for others of you if you're new to Unity. So what we need to do is add an animator component which assigns animations to game objects through an animator controller. We'll talk about animator controller in a moment, but just a reminder that when you have any game object, these things that we attach to the game object are components, and components give behavior to our game object. So we have a transform component, we have a mesh renderer component, I'm just clicking on them, that's why they're opening and closing, we have a nav mesh agent component, and we're going to add another component right now, which is animator. Okay, click on the animator, that's now added an animator component. And you can see the very top line is controller, and it's looking for a runtime animator controller. What is that? Well, an animator controller is an arrangement of animations and transitions. So a transition is going from one state to another, and we can think of this as a state machine. I'll show you that in just a moment. We also need to be implementing animations. We downloaded a couple of animations in that asset pack that I just showed to you and gave to you, and they are specific pieces of motion, obviously. That's what animation is. And we're going to be implementing a blend tree. Why a blend tree? Well, that allows us to have multiple animations and for them to be blended together smoothly. So we can blend from idle, which is just kind of standing around and wobbling a bit on the spot, through to walk, through to run, based upon a value that we use to say how fast the player is going. So if the player is currently at 0, then they'll be in idle. If the player is currently at 5, they'll be running. So let's implement all of these things we've just been talking about. We have our animator. We need an animator controller. So within our assets directory over here, I'm going to right-click, create folder, and characters. Ruined the surprise by already having it in there, didn't I? Okay, we have our characters folder. Double-click on that. In here, I'm going to right-click, create an animator controller. Halfway down the middle. And this I will call character. This character. And we're going to use this character animator controller, the thing that drives the animations, probably for the player and for the enemies and for the NPCs, because there's a lot of commonality. Everyone needs to walk and move and run, for example. So I've got a couple of windows that you might not have yet. We'll give ourselves a bit more space. Go up to Window and Animation and find Animator, and then move it wherever you like. I've got mine down in the bottom here. Just a reminder, if I haven't told you this already, to move, you hold a tab. You can move it and snap at different parts of the screen. I'm guessing you already know that already. And we also need our animator window. So window, animation, animation. It might be in a slightly different spot. Unity likes to update this. This is updated recently in the version I'm using. So there's a little bit of me saying, hang on a minute, where's that window that used to be just there? So animation. Okay, so we've got animator and animation. And to get the same setup as me, make sure you're clicked on the parameters tab, not the layers tab. And in animator, you can see we've already got a couple of states that don't really do much or mean much at the moment. Entry just means this is the very start. When this game object or when this animator comes to life, we are starting off at this entry point and going somewhere. At the moment, there's nowhere for it to go to. So we're going to right-click and create state, and we'll create from new blend tree. So this is creating a blend tree. And you can see here, if we click on blend tree, we have an opportunity to rename this. I'm going to rename this locomotion. Look, everybody doing a brand new dance now. Locomotion, that's an old song reference for those of you who are old like me. Locomotion. Okay, doesn't look very interesting just yet, but if we double click on locomotion, we go inside to the blend tree where we can add some cool stuff. So I'm going to click on blend tree. You can see I've got this preview tab window here. It might be down the bottom for you. It snaps down there. You can drag it up a little bit. Currently there's nothing going on. That's because we don't have any motions. We can click our button here and add a motion field. Now I was going to go through and just show you all this, but I want you to do a little bit of discovery here to do this yourself. So here's a challenge for this video to add our motion fields. So add 3 motion fields, and I just showed you here. You can click on the plus button to add motion fields. So add 3 of them, and then using the selector button, that's the little circle with the dot in the middle, add an idle, a walk, and a run to these fields. And then in the preview window, click play. So this is the preview window that I was showing you just here before. And then slide the blend value. See if you can find the blend value to see what happens within our preview window. Okay, so it's a pretty simple one in terms of there's not a lot of coding. Well, there's no coding. It's pretty straightforward, but just a little bit of finding where things are in the interface, just having you do it instead of following along directly with me. So get it to the point where you have a character that has 3 states that you can blend between by sliding the slider up and down. Okay, hopefully you did that challenge. I know it was a little bit of a different one to the sort of challenges we do usually, but let's go through it together so you can see what I did. Adding 1, adding 2, and adding 3 motion fields. Click on the selector, and these are the 3 animations we downloaded from our asset pack. If you don't have these, make sure you download the asset pack that I've given you. I'm going to add idle, and then selector again, add walk, and then for the 3rd motion, click on the selector, and I'm going to add humanoid run. So I have my window here. I'm going to click on play. At the moment, not much is going on, just standing there idling. Just a note, up in the top right, you can change the speed with which the preview happens. You can make it really slow. That's just changing the preview of the animations. But I'm going to drag this up to 1, so it's playing at the proper speed. And I've found my slider just here on the blend. As I drag this up, he's moving from idle to walk to run. And if you want to see what's going on up at the top here, we've got the blend where one animation is decreasing and the other one's increasing. So this point right in between, so it's going to be at 0.75, which is halfway between the walk and the run, he's doing a blended walk-run. So this is taking the animations and blending them together, which means we're not popping. We're not just walk, 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 and then all of a sudden pop into run and then pop back to walk, 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 and then popping into run. This blend allows it to feel a lot more organic, which is really cool. It means you create 3 animations, but you get this massive variety, this organic feeling to the player. Okay, so that's it. That's what I wanted to show you in this video in terms of setting up a blend tree, starting our animation. Our character's not going to do anything yet. If you're going to click play, he's going to be a little bit broken because we haven't hooked up this relationship in code to say when the player is at 0 speed and when the player is at a greater speed. So that's what we'll need to do in upcoming videos. So great work, and I'll see you again shortly. Off for now. The other thing we'll do while we're here is just rename, while clicked on player and clicked within our animator window here, make sure you clicked on blend tree. If you can see locomotion, then you need to double click on that to get into the blend tree. Click on blend tree, click on blend, and then slowly click on it a second time. We're renaming it. If you just right click, there's no rename option. It's one of those wacky ones. You have to click and then do another slow click, and we can rename this to forward speed, because that essentially is what we're doing here. We're saying how fast are we moving forward. If I click play and just move around a little bit here, how fast am I moving forward on this, which for our character is the Z axis, Z or Z axis. So forward is Z, and that's all the character can do. I want to show you, for a little bit of context, some terminology, just so I know you're really clear what we're up to at the moment. So we're going to be using the term velocity, and velocity is essentially the rate of change of our position over time, or put another way, it's the speed and the direction of something. So for example, a car traveling north at 50 kilometers an hour, that is its velocity. Its speed is 50 kilometers an hour, and its velocity is north at 50 kilometers an hour. And our NavMesh agent that we've implemented already is thinking in terms of velocity. It's saying, I've got a direction that I want to move and a speed with which I want to travel there. And our character's locomotion animations, so its idle, its walk, and its run, are only interested in the forward speed along the Z axis. You can see as we speed up and slow down, it's just changing the blend of the animation that we've hooked up already. And if we look at what's happening at the moment, I'm sure you've clicked play already, but let's click play and just see what's going on. When we click play, our player just slides around and stays in the idle state. And what I'll do while I'm here actually is just move the camera in a little bit. So I'm going to make sure that my character is positioned at 0, 0, 0. Cool. Make sure that my follow camera is also positioned at 0, 0, 0, so that I know it's pointing right at the character. If I click on the main camera, I can see the character's in the middle. It's a bit too far away, so I'm going to scroll out where I can see the camera. While clicked on the main camera, I'm just going to find the axis that will bring it towards the character, which I think is the blue square here between the Y and the Z, and just bring it on closer into the player. So if you hold in that space in the middle, it's moving on two axes at the same time. That's pretty good, nice and close, and then just a little bit left to right. Okay, now when I click on play, it should be somewhat centered and a little bit closer. Okay, but we're flying around. We're doing this little glide. So let's talk about how we can make our player actually run. So our goal here in this instance, first of all, is to get the global velocity from the NavMesh agent. So the NavMesh agent knows how fast our player needs to be going and where it needs to be going. Next, we need to convert this velocity into a local value relative to the character. So what I mean by that is the character's interested in, I need to run forward, I need to turn left, I need to turn right, and the velocity we're getting from the NavMesh agent isn't giving it to us in terms of turn left, turn right. It's giving it to us in terms of you need to head to the X, Y, Z coordinates in this direction. So we need to convert it into something that the character knows, which is going to be the local value for the character. And then we need to set the animator's blend value to be equal to our desired forward speed. So in other words, if we want to run fast, we have it maximum speed. If we want to run slow, we have slow speed. And I want to give you a little bit of context here as well. So if you find the animations that we've been given, so click on animations unarmed, you'll see that we have the three in there. Idle, run, and walk. I'm just expanding them out here. The animation itself is the grey box with the play button on it. You see when we click on that, we get this generic avatar, or we should. But the main thing I'm interested in here, if you just pop that guy out of the way, you can see under all the information on a particular piece of animation, down the bottom here, average velocity 0, 0, 0. So that's X, Y, and Z. It's saying at idle, we're not expecting the player to change the transform from where it is, maybe wobbling a bit on the ground, but not actually to move anywhere in the world. If we click on run, you'll see that the average velocity is 0, 0, and 5.662. So this is what the animation is wanting us to do. At full run, full speed run, it's expecting us to be moving with a velocity in the Z direction of 5.662. And then for walk, it is 1.558. Now, something a little bit nifty we can do when we click on our blend tree, you can see at the moment we've got our walk set to 0.5 and our run set to 1. What I could do in here is manually add in the values that I just found that our animation system thinks is our walk and thinks is our run, or I can click off animate thresholds and compute thresholds, where I compute based on velocity Z. When I click that, you can see that our threshold is now 1.55 and 5.66, exactly as our animations was expecting and told us it was expecting in terms of those velocities, which is really cool. And that means that as we drag forward, I'm going to click on play here, as we drag forward, when we're at 1.55, it's the sweet spot for walking, and when we're all the way up to 5.66, that's where it's expecting to be running. Now it's going to correspond when we click back over on the player, we find the NavMesh agent. So the nav mesh agent, we've got a speed here. If the speed is greater than 5.66, then the nav mesh agent's going to say, move a whole bunch of speed, but the animation says, well, I was only expecting to go 5.66, man, so I just can't keep up with you. So in here, I'm going to put in 5.66 as our speed and say that is the maximum speed with our current configuration that I want my player to be running across here. And if I want my player to be moving with any more speed than that, then I'll need to alter my animation, so speed my animation up, or vice versa. If I want to have go slower, then I need to do something with my animation, which we can do, but for now we're just going to go for a nice basic 5.66 speed based upon the animations that we've been given. Okay, so let's make all this happen. Let's make our character's animation update. Just a reminder of what we're doing here. If you're feeling advanced, you can take on this as a challenge. I've got a more simple tuning-based challenge for this this lecture, but if you want to take this on, if you're feeling advanced, then by all means this is your challenge to take on. Otherwise, let's go through this together by starting off and opening up our mover script. So down in scripts, open up mover. And the first thing we need to do is, well, we need to, on update, we need to be changing the animation of our player. So after we've figured out where it is we wish to move to, so let's call a method in here. We'll create just in a moment. We will name it update animator. Semicolon, and down the very bottom underneath move to cursor we will, so for me line 29, we will create a private void update animator parentheses. Okay, and our curly braces, and then a reminder of what we're trying to achieve. We want to first get the global velocity from our nav mesh agent. So how are we going to do that? Well, we're going to create a variable of type vector3, which we'll call velocity, and that will equal get component. What component do you think it is? Little micro challenge for you. If you've been paying attention, it should be easy. It's the nav mesh agent component, and then parentheses dot velocity, semicolon. And then, as I mentioned in my steps, next we need to convert this into a local value relative to the character. So the way that we do that is, again, creating ourselves a vector3. We'll call this local velocity. And that will equal a slightly new concept. I'll show you something here, which is transform.inverse transform direction. And then what are we going to pass in? We're going to pass in the velocity that we wish to be doing our inverse transform direction on. So velocity. And semicolon. If you want to read up more about inverse transform direction, basically it's taking from global and converting into local, but jump into the Unity docs. I've given you a link against this lecture if you want to know a little bit more about that, but that's pretty much its function in life. And now we create ourselves a float called speed that we're going to be using when we update our animator, and that will be equal, what are we interested in? Just the local velocity dot z, because all we want to know is the z speed, how fast I should be moving in a forward direction. And the final step, I'll have a look on my list here, set the animator's blend value to be equal to our desired forward speed. If you remember, this is our forward speed that we've created here that's going to go from 0 to 5.66. And the way that we do that is get component. And then which component do you think we're updating in here? It's the animator, parentheses dot, we'll use set float, and in here we're passing in the string reference, and of course we're going to mess up the string reference unless we go over in here and copy it. So go back into Unity, find forward speed, copy that so you get it exactly buttoned up, and then paste that in. String references are not ideal, but sometimes you got to use them and you want to make sure that you are very careful when you do, comma, speed. So quick recap, we're getting the velocity from the nav mesh agent. We're using inverse transform direction to make that a local velocity, so it's meaningful for the character. And then we're creating a variable called speed that we're going to pass into our set float animator in relation to the forward speed of the animation, which is the local velocity.z. Okay, save that up, head over into Unity, see if this all works, click on play. I'm going to give myself a little bit of space here for this big moment of excitement. Click on play. Okay, and as we move, the player goes from stopped to moving, and you can see we've got some delightfully bad motion going on there at the moment, which is great, but this is working. You can see down the bottom here, the forward speed is going from 0. If I just run in a straight line, going to 0 up to 5.66 and then returning back again. Now, turning around is a big problem, so that is something I'm going to give to you as a challenge, is to go into the player, find the nav mesh agent, and tune your character's movement so that it turns and accelerates in a way that feels good for you. So pause the video, take on that challenge, and I'll see you back here when you're done. Okay, making an RPG has a lot of tuning and tweaking in it. So here's us starting that journey, very exciting. Speed, we're leaving at 5.66. The angular speed and acceleration have a relationship to one another. I'm going to do this in play mode so that I can play around with it as we go. You can see a lot of the issue here is how I turn. I'm not starting to run quick enough. It's all looking a little bit messy. So my angular speed, I'm going to see what happens if I increase that to, say, 1,000. Okay, he turns around a lot faster and starts moving a lot quicker. That looks better. I'm going to see what happens if we crank it up to, say, 5,000. Okay. Yep, that's feeling a bit better. Didn't seem to make a huge amount of difference. Acceleration, what happens if we drop that down to, say, 10? My guess that is the wrong direction, because it's the acceleration of turning as well as the acceleration of running in a new direction. So I'm going to pump that back up the other way, say 50. Okay, that was a pretty good turn. He's got a pretty abrupt stop, but he's taking a couple of steps at the end, yep. So if I'm battling a whole bunch of enemies, click, 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 attack, attack, move, run. Let's make sure that it works with the nav mesh agent. I'm going to click on the navigation button, and then you can see when we're doing that, you can see this nav mesh information with a gizmo. Make sure you got your gizmos turned on. You can see what part of the nav mesh it wants to go to. And this blue line is the nav mesh agent's vector that it's saying, let's go in this direction. And then our character animation is updating to head in that direction. It's all looking pretty good. So a reminder again of the values that I had in there. Back on my player, of course I didn't save that, but no worries, I was remembering it. I had 5,000, and my acceleration I had 50, and then I'm going to click on player and click on the overrides button, apply all, so this applies back to the prefab. Fantastic. Awesome work so far, and I'll see you in the next lecture. Left mouse button to continuously move. Think about where in our code this might be controlled, and to use the Unity documents to help you make a slight change. You might know the answer already. If not, have a look in the Unity documents and see if you can find what you could change to do that. So it's a little bit vague. I haven't given you too many clues beforehand, but this is more of a, I want to teach you how to think through the problem kind of challenge. So here you go, jump in, take that on. I'll see you back here when you're done. Okay, hopefully you did give this a try. You didn't just look at it and say, oh, I don't even know where to start with this. But if you are struggling with this, not a problem. This is part of programming, and let me show you the thought process I went through. So I want to go, instead of going click, 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 I want to hold down click. So I know that's going to be in my mover script and something to do with my mouse. And we're using input get mouse button down. So straight away I'm like, okay, it's got to be something to do with this. And the way that we can get clues on this is we know that we have our get button down method here, and we know that there's going to be more than just that we can use. So we're looking within the input class, so input dot something. If I jump over to my Unity docs, have a look here, I can search for Unity, sorry, search for input. Of course you're in Unity, Rick, what are you talking about? So search for input, and within input we can see what's going on here. If you want to take the time, read it, really deeply understand it, but the quicker way is to go and find get mouse button down and sort of see what else is going on around there. So get mouse button down returns true during the frame the user pressed the given button. So it's returning true once, just when we click down. It's going to return true again when we click down another time. Let's have a look around here. Right above get mouse button down returns whether the mouse button is held down. So we want this. We want it to be returning true if the mouse button is held down. So this is a really easy tweak. We just go into our code within update. Oh, don't hit the wrong button on your keyboard. Within update, input.get mouse button down. We're just going to remove the down and save that. We'll check that this works. It's always good practice. Here we go. Let's check, and it's working nicely. Okay, and we'll even do a little spin around on the spot. Whippity-doo. Okay, so that's the first thing. I think that makes our game a lot tighter. Just a very easy little piece of code tweaking. The second thing, you might not have had this yet, but we will get some issues as we put more stuff into our game where there's a jitter between the player and the camera, where it looks like the player is kind of skipping forward or skipping backwards. And that's something that we could wrestle with and scratch our head for a while and not know what's going on. But Sam and I have already scratched our head and wrestled with that, so we'll save you that. I was hoping we'd see it in the game so you could see the issue and we could go through the process of figuring it out, but it's a little bit difficult when you can't actually reproduce it. So what is going on, or what could go on in that instance, is we have our camera is being updated each frame within update, the follow camera, so it's moving along as it's trying to track where the player is. Track. The player is moving along as well. It's got its animations, got what's going on in the nav mesh. Sometimes there's a little bit of a mismatch where the camera tries to move first and the player hasn't yet moved. So the camera moves a little bit, then we see the player move. Other times the player moves, then we see the camera move. That sort of mismatch, when you see that going on, the thing I want you to think about is what's happening in terms of order of execution. So if you're not familiar with order of execution, you can jump over into Google, search for Unity order of execution. I've given you a link to this as well. Click on that, and you can see that there's a specific order that Unity executes its functions, executes what's going on each frame. And if you scroll down, you'll see here's the script lifecycle flow chart. And we can see right at the very, very start, the very first that's going to happen on initialization is awake. And within our game logic, this is what we're interested in here. We have update, a bunch of other things happen, internal animation update, and then we have late update. So we have an option in there. If you find that something really needs to happen after something else, one of the ways you can do it is say, well, let's put this in late update. So which do you think we need to put in late update, our animation or our camera? Okay, if you said camera, you're right. So we want our animation to do its thing on a frame, and then we want our camera to follow that afterwards so we don't get that jumping where the camera is trying to guess where the character's going to be. So go into your follow camera script, and where we have void update, we've simply changed that to void late update. Okay, and once again, just jump back over in there and test that we haven't created any issues. It should probably look very similar to what we had just now because we weren't seeing the bug all that much. Okay, cool. Yep, looking nice and smooth. Camera in late update. Now what we're going to do at this point is declare our basic movement done. I'm pretty happy with this. There's a little bit of foot slipping. I can tweak and tune, I think, his movement a little bit more. Not super happy with the turning circle, but until we get more things going on in our game, we don't want to finesse this right down to the core. We need to have an enemy to dodge around, and we need to have combat happening. And what happens when I swing the sword? Does that still have my movement look how it's supposed to look? Do I need to move my camera in or my camera out? So at this stage, I think we have enough to say, yep, basic movement is done. So let's move on to the next section. So a couple of other things to tidy up this section of the course that I'm going to show you. But for now, we're going to declare basic movement done. Great work, well done, and I'll see you in the next video.
Hello and welcome. In this lecture we are with me, Sam, rather than Rick, and we're going to be talking about folder structures and the folder structure that we're going to be using throughout this course and why it makes sense for us. So at the end we're going to end up with a nice clean folder structure. You can see the top level of our assets folder structure is pretty neat and not very many folders, and even the second levels, as you can see over here in this left hand side of the pane, is looking pretty good and sensible. And I'll also explain why it is laid out this way and what the reasoning behind it was for us and how you might come up with your own folder structures for your own projects. So let's dive in. So over the course of the past section, we have got to this folder structure. It's kind of evolved out, and Rick has been heading in a sort of direction. I just want to take a minute to step back and tidy it up a little bit and talk about some of the decisions that we're making here and why we're going down this route with the folder structure. So first of all, let's have a little chat about why you'd have different folders at the top level. By the top level, I mean here at the root of assets, we've got things like asset pack, characters, game, scenes. What's a good reason to have a folder up here at this top level? So one good reason is if it is for a different discipline. For example, our scripts folder has a good reason to exist here because it is for programmers. For example, you might have a different folder for modelers, for designers, etc. Also, different organization. Usually different disciplines require different organizations within the folder structure. So you start with a different folder at the top level, and then within that you can have a different layout depending on the different disciplines' needs. That's what I mean by different organization of folders. And then another good reason is if there's too much nesting. If you have got to go folder within folder within folder to find an asset that you use very, very regularly, it's a good idea to bring some folders out, to bring it out to the top level so that you can more easily access stuff. You don't want to be drilling down all the time. It's no good just having one folder at the top level if you have to always click into it, for example. So these are the reasons behind our folder structure. I'd like to take a sec to have a look at the particular folder choices that we've made. The first one that stands out is the script. As I've said, this is for programmers and the content of it is code. So let's have a look at that. Let's check this is correct. We've got scripts and inside it we've got code. That seems right enough. But then I've said the structure is by namespace or by feature. So we'll talk about namespaces later on. Don't worry about this. But by now we'll just think about features. So what kind of features have we got here? At the moment we've got a movement feature, a movement kind of feature space, and we've got the follow camera, which is more to do with, well, I don't know, it's more the kind of core of an RPG. So I'm going to move these into folders already. I'm going to create some folders, one for movement, and all the scripts to do with the movement feature will go in there. At the moment we've only got one, but we will have more. And a word of warning at this stage, because if you have this script that we're moving around open in Visual Studio Code while you're moving it somewhere else, it can lead to you saving in Visual Studio Code into the old location. So make sure you close any scripts in Visual Studio Code before you start moving them around. And then we're going to add a new one for kind of core features, a new folder called core. And I'm going to move the follow camera into that. So that's what I meant by that layout. We're going to have scripts, programmer, content, and the namespace feature. So the idea here, the reason we're dividing it by features is because we want to minimize the dependency between different features. We don't want movement having to depend on lots of other features because it makes it a nightmare for us to code when we need to go and change how movement works if we have to be thinking about how combat works and how all these other things work. So that's the reason for splitting it down by feature. And it's also logical and an easy way to find your scripts. Then we have got the game folder, which is going to be mainly for the designer. If you don't have a designer, if you're the same person, it's when you're putting on your designer hat and deciding to do some design work. And the contents of this is going to be prefabs and scriptable objects and other Unity configurable type things, stuff that you create in the Unity editor, basically. So we've got this game folder, and at the moment it has got prefabs in it. It's got a follow camera, and it's got the player. And what else have we got? We've got this characters folder, which at the moment contains the character controller. Well, I would say that is something the designer creates as well, particularly the animation flow and things like that. So I'm going to stick that characters folder under the game folder to tidy up a little bit there. You'll notice the player is also a character. And what I've said on this line is that the structure should be by entity. Previously with the scripts we were doing it by feature, so movement, etc. By entity is more like saying by the characters, by the weapons, by the players, and so on and so forth. So at this level of structure in the game, we're going to have the characters. We might have another folder for weapons, like that, and then potions, etc., and things like that. And also I'm going to have a kind of core folder because we want to put our follow camera in core and our player in characters because that's the logical place for it to be. Now, you can organize characters further. If you've got lots of assets that are relating to the player, you might put it in a player folder, but we're going to leave that until a little bit later. Now, the next thing is the scenes folder. This is where the level designer lives. Again, maybe if it's just you putting on your level designer hat when you're going to do some level design, that's where you're going to put scenes, terrains, nav meshes, things relating to a particular scene or used by just the scenes, not used kind of across scenes and things like that. And the structure here is pretty simply going to be by scene. So we've got our scenes folder, and under that we've got a sandbox folder. The scene sandbox is not in the sandbox folder. I think that's fine, again, because too much nesting means that when we need to get to the common things like the sandbox scene, it can make it hard to get to. So I'm leaving the scene, which is most accessed outside, but any assets relating to that scene go inside the sandbox folder. And there is one asset that has slipped the net. It's this new terrain asset, which is actually should be called something like the sandbox terrain. And we can put that sandbox terrain in the sandbox folder of the scenes folder. So if we added more scenes in here, we would add more folders. I think that makes quite a lot of sense. Let me know what you think. Then the next choice is for having a UI folder. I'm going to create this UI folder even though we don't have any UI to put in it yet. This is where we're going to put different screens. So inside the UI folder, you might have a folder for the pause menu. You might have a folder for the, what else? We might have the inventory, and so on and so forth. That's what I mean by organizing it by the different screens. Then the asset packs. This is pretty self-explanatory. When you import an asset pack, our asset packs will automatically go into the asset pack folder. If you bring in your own asset packs, I recommend you move them into the asset pack folder. The idea here is that we don't touch anything that goes within these asset pack folders. We don't add anything, we don't remove anything, we don't change anything, because if we do, when we want to update asset packs, it'll be really hard for us. And we have accidentally done this with the terrain textures asset pack. So you see these 4 assets here are layers. They're layers for our terrain. And because they relate to the scenes, I'm going to take them over to a common folder in scenes. We might want to use it between scenes, for example. So I'm going to create a folder called shared in the scenes folder and go back to those terrain textures and pull them over into that shared folder. So now we've left our asset packs untouched in their original state, which means that if you need to update them, because we will provide updates to these packs, we'll be providing more textures, more animations, etc., then you can go ahead and do that. And finally, a note about audio and models. We're not producing them as part of the course, so we're not going to be putting them in these audio and models folders. But for example, if we go up to the root of assets, you might create a folder for models. You might create a folder for audio. And if you create any of your own voice acting, you might put stuff in audio. If you do any of your own modeling, you might put stuff in models. And I'll leave the layout of those folders entirely to you, whatever makes sense. I'm going to delete them, though, because we don't have anything to put in there. And we're likely not going to be using them ourselves in this course. Okay, so that is the summary of our choices. Hopefully you were following along. Maybe you did some reorganizing of your own stuff, but now is the time for you to really think about the organization of your own project. So I'd like you to take a moment to tidy up your own project, look through, see if anything is different from ours. Maybe if you have another project somewhere sitting around that you think was really messy, you'll go and try and apply some principles to that. So not even the project we've done so far, but a different Unity project you've had. What structure works for you? Think about the particular project. Think about the particular needs of the project. I strongly recommend you don't touch assets, though, especially for this course, because we will be updating things like animation packs, and it'll just make your life easier. And then celebrate being organized, and maybe you go and share your organization over on the forum, what you've chosen. Give us some feedback about what you think about our folder structure and whether you've chosen to do anything different and the reasoning behind that. So I'm just going to go straight on to the next video here. So after this video has finished, go and do your organization and come back and follow the rest of the course.